Here's some gas law questions. First one says you've got let me do my P1 stuff. P1, V1, N1, T1. A 43.9 milliliter sample, so the volume 0.0439 liters of hydrogen, okay, at STP. So standard temperature is 270, right down here, 273.15 Kelvin, and standard pressure is 100.000 kilopascals. So they want to know how many grams. Well, my formula is only going to give me moles. So once I find moles, then I can change and find mass from that. So I'm not changing pressure, volume, moles, or temperature. So it's an ideal gas law. Okay, and I'm looking for moles. So moles will be equal to PV over RT. So the pressure is 100 kilopascals. The volume, 0.0439 liters, divided by R, 8.314 kilopascal liters per Kelvin mole. And the temperature, 273.15 Kelvin. So let's see what that comes out to. Calculator. 100. Whoops. 100 times 0.0439 equals, divided by 8.314 and 273.15. Okay, so I'm getting 0.0019331 moles. And they want to know grams. So to get grams, I have to use this formula. Moles is mass over molar mass. Solving for mass is going to be moles times molar mass. So the moles I just got, 0.0193331 times the molar mass of hydrogen. It's H2, so hydrogen's 101 times 2. So this would be 2.02. Okay, my other answer times 2.02. So I'm getting 0.00390485 grams. Round it to, looks like I have 3 sig figs, 0390. Okay, I don't see that number up there. And I wonder if the number is different because they use the different standard for kilopascals, or if they use the different standard for the temperature. At any rate, we're fairly close to one of the answers, so I would probably go with that answer right there, because that looks like the closest to my number. Let me try it with the 101. 101.325 times 0.0439 divided by 8.314 and 273.15 times 2.02. Oh, that one comes out right. Oh, no, it still is off a little. Still off a little. Anyway, I think that the work that I'd seen you do was correct. Let's take a look at the other ones. Okay, so here I have 2 balloons, both the same size, same temperature. 2 balloons, same size, so volume is the same. We'll say volume is X, and temperature is the same. We'll call it Y. Okay, the hydrogen balloon, this is hydrogen, it floats, and the carbon dioxide sinks. Which balloon contains a greater number of molecules? So if they have the same temperature and same size, the only thing that could differ would be pressure and number of moles inside. Okay, let's maybe get a clearer picture of this. So I have a balloon and another balloon, and the volume of this one is the same as that one. Say it's 100. Say the volume's 100, so this volume is 100. And say the temperature is 273.15, and this 273.15. Now, based on the fact that we're not sure how many moles are in each one, but if there was more pressure in one than the other, then the balloon would be bigger. So I think that the pressure has to be the same. Let's call the pressure 100.000 kilopascals. So pressure in this is 100.000 kilopascals. Now, if we were to do our combined gas law, P1V1 over T1N1, P2V2 over T2N2, if these numbers, like if the two pressures are the same, the two volumes are the same, and the two temperatures are the same, it has to be that those two moles are also the same. So I'd have to say that they both contain the same number of molecules. Carbon dioxide is heavier than hydrogen, but just according to our universal gas law, it looks like they should have the same number of molecules. Now, another question about the popping balloon. So I have a balloon here, and it's got 8 liters. And I heat the balloon up so that the temperature measured in Celsius doubles. Well, let's put some numbers in. P1V1, T1N1, P2V2, T2N2. So I'm starting the volume at 8 liters, and I want to know what the final volume is. Hopefully it's not more than 16. Then they heat the balloon up so the temperature Celsius doubles. So let's say Celsius, 25 degrees Celsius. So temperature 2 would be 50 degrees Celsius. But now if I convert those, it'd be 298.15 Kelvin. And then this would be 320, 273. So 323.15 Kelvin, I think, is the second temperature. Now, it doesn't say anything about pressure or moles, so let's assume that doesn't change. And the pressure will probably be the same, it's just that the volume changes. So that might be a wash. So we're just looking at volume and temperature. Now, this difference probably won't make any difference, or not much of a difference, if I use a different value to start with the temperature. But as it is now, I can do V1 over T1, V2 over T2, and let's see what happens. I don't think that the volume is going to increase that much because Charles deals with Kelvin temperature, and those didn't double. So if they didn't double, I don't think the volume is going to double at all either. But let's see. So I'm solving for V2. So V1 T2 over T1. V1, 8 liters, times temperature 2, 323.15, divided by 298.15. And when you multiply those, this into this doesn't go 2 times. So there's no way it's 16. So it's going to be less than 16 liters. Remain the same. Volume won't remain the same because you're heating it up. Charles' law says if you heat it up, you're going to have more volume. Expand to a greater volume? No, it's not going to be bigger than 16. Volume less than 6 liters and not pop, that's the one right there. Expand to a volume of 16 liters. No, it won't expand that much. Won't expand that much. Has to be that one right there. All right, hopefully that helps you with those 3 questions.